Quantum numbers are very convenient when you're talking about electrons, and they essentially describe an electron's address in an atom. And they do this throughout 4 distinct numbers. The first number, which we kind of call N, is our principal energy level. The second is our subshell, and that's given L as a name. The next is M sub L, which is our orbital, and M sub S tells us the spin. So let's go through those and kind of talk about them a little bit more. So N is our principal energy level. So that's just the energy level that the electron is in. So that cannot be 0. But N can equal 1, 2, 3, 4, on to infinity essentially, as long as it's an integer. Okay, so now moving on to our L, which designates our subshell or sublevel. We have 4 options that we commonly use, and that's our S, P, D, and F sublevels. And what we see is S is given 0 as its number, P is given 1, D is given 2, and F is given 3. And if there was a sublevel after F, then that would be 4, and etc. So the general rule of this is that your L number has to be less than or equal to N minus 1. And that's because if we think about it, if we have 1 for our principal energy level, well, we know with 1 energy level there's only an S sublevel, so we could only have S. If it was 2, we could have an S or a P, etc. So now let's look at our M sub L, which tells us which orbital we're in inside of that subshell. And the nice way to look at this is kind of to draw them out, and you can see a pattern. So for our S sublevel, we have 1 orbital. So S equals 0. And we put a 0 for that number. So our number for an S subshell, that orbital is 0. For P, we're going to have that equal to 3 different orbitals. And we put 0 in the middle, and it's -1, 0, and 1. So we're mirroring around 0 here. If we looked at our D, we have 5 orbitals. So we're going to start in the middle with 0. We can come back 2 and go forward 2. So we have -2, -1, 0, 1, 2. So this is generally the pattern. So the pattern and also, essentially, you know that M sub L can equal -L to positive L. So if we look at our L number, L for S is just 0. So -0 to positive 0 gives us just 0, which we said a second ago is true, because for S we only have 1 orbital, so it has to be 0. For P, our L value is 1. So coming to our M sub L value, we know we could have 3 of them, so we got -1 to 1, and if we do -L to positive L, we get, once again, -1 to 1. So that's a nice way to make sure you're doing it right. And the last number, quantum number, is M sub S, and that tells us the spin of the electron. And use a positive 1/2 or a negative 1/2 to say which way that spin is. So let's look at helium real quick, because that's our easiest example to show both a positive and negative charge. So it only has a 1s orbital, and it has a positive and a negative electron, or positive and negative spin. So when it's pointing up, that is going to be our positive 1/2. When it points down, that's going to be our negative 1/2. And that's fairly arbitrary, but that's the general accepted way to do it. If you wanted to switch them and have everything going down being positive, everything going up as negative, that would be acceptable, but in the literature that's going to become really confusing. and now let's look at two examples down here. We're going to label an electron in oxygen and magnesium. So let's determine what our quantum number would be for this electron here. So in oxygen, first we need to find out its principal energy level, which we see it is 2p here. So we know our first number is 2. Now we need to find our subshell. Well, it's in the p subshell, we can see. So for p, we use 1. Now looking at it, we have to figure out which orbital it's in. Well, it's in the first one. So that's going to be -1. And then we have to identify its spin. So since it's pointing up, I'm going to say that's +1/2. So that's what that electron would be given as its address. Looking at magnesium, let's classify this electron. So looking at its principal energy level, we get the 3 for its energy level. It's in an S subshell, which tells us that's 0. We know that M sub L has to be -L to +L, so that's going to be 0 again because there's only one orbital for S. And then our last number is our spin, and we look at that and it's pointed down, so we're going to say -1/2. So that is how we use quantum numbers to describe electrons, and how that can be useful with our electron configurations down here we've shown in our examples.